right, hi everybody. After talking over with some students, looking at the scientific notation problems, I decided that maybe I'd make a video of some of the harder problems. So I think most of you were able to solve number 12, but I think a lot of you might need help with 14, A through D, and I'll probably also do 16, A through D. Please don't watch this whole video unless you need to. So if you're struggling with it, let me help. If you're not struggling with it, you don't need to watch this video. If you're only looking for 14D, then scoot ahead and watch just part of the video. All right, so there's a couple things that I'll say right off the bat. I put the first problem on the screen. I will say that there are numerous ways to solve these problems, but there are some ways that I think maybe are better than others, and that's what I'm going to try to show you here. A couple things that I'm noticing right off the bat with this problem. Number one, I see that the units are incorrect. So they asked us to, oops, that was not the right thing to do. They asked us to answer the question in kilograms, but I noticed that one of our units is in grams. So in order for us to be able to add different masses, the units have to be exactly the same. So we're going to have to convert that one that's in grams. We have to convert that into kilograms. The other issue, and this is important, is adding using scientific notation. Remember that the rule for adding is that you're allowed to only have as many decimals as the one that has the fewest decimals, your least precise measurement. Well, in order to have decimals, you have to be really written in this circumstance, you have to be written in scientific notation. So sometimes students choose to convert the 1.26 times 10 to the 4. They multiply it out and they figure out that that's 12,600. But then you can't really add that because it doesn't have the decimals. So the rules for significant figures become confusing if you don't have it written in scientific notation. So I'm going to help you keep it in scientific notation so that you can do all that. All right, so we're going to start, first of all, by converting it, converting that second, gosh, I can't think of the word for that. Anything that's in the parentheses, we're going to convert that into grams. I'm going to do it in a way that takes a little bit longer, because if you get how to do this now, we're going to use conversion factors. I'm going to show you how to use a conversion factor all the time in upcoming units. So if you get the hang of that now, you're going to be ahead of the game for everybody else. So I'm just going to show you this really quickly. So let's take that first unit that we have, or that first amount we have, 2.5 times 10 to the 6 grams. Now, if you haven't discovered this, there's a little table in your textbook on page, I think 33, that just reminds you of your prefixes in metrics. And you should have learned that in junior high, but maybe you haven't studied that in a while or forgotten it. So go back to pages 32 through 35 just to remember your metric units. So you should know that for every 1,000 grams, there you have 1 kilogram. And when you write it like that, that's called a conversion factor. You can also write it the opposite. You can say for every 1 kilogram, there are 1,000 grams. Well, I want you to use one of those conversion factors in order to convert the grams into kilograms. And this is where students get stuck. They don't know whether they're supposed to multiply by 1,000 or divide by 1,000, the number that they have there. So I'm going to show you how you always know the right answer. So let's get rid of these conversion factors, and I'll show you how to make it work. And this will be true in a dozen other things that we do in this class. So the way I make it work is I write out a line, and that line is going to be for my conversion factor. And I see that we are originally in grams. We have grams to start with. So I'm going to ask you to put the grams on the bottom of your conversion factor. When you have a gram that's on top, a unit that's on top, and the same unit that's on bottom, they cancel each other out. So we have grams here and we have grams here. They cancel each other out. Now I want you to put the kilogram on top. Whatever unit you're left with, that's the unit that your answer is going to be in. So we're now going to convert into kilograms. So now we know it's kilograms on top and grams on bottom. So we said it was 1 kilogram for every 1,000 grams. So now when we look at the problem is 2.5 times 10 to the 6th, that amount, divided, or you could say, sorry, I'll say it more simply, 2.5 times 10 to the 6th times 1. Most people skip that step. And then divide that by 1,000. So if I type that into my calculator really quickly, 2.5 times 10 to the 6th times 1 divided by 1,000, we get 2,500 kilograms, 2,500 kilograms. Now, if I'm going to write that in scientific notation, I could write it 2.5 times 10 to the third. However, notice that your first parentheses, why can I not think of what that's called? The first amount in the parentheses is written times 10 to the fourth. So I'm going to actually, instead of writing this one as 2.5 times 10 to the third, I'm going to scoot that decimal over one more spot. So it's going to be 0.25 times 10 to the fourth. Now, because both the exponents are the same, I can actually do the math here. So let me switch colors one time to make it pop for your eyeballs a little bit. So we're going to start over. So it is 1.26 times 10 to the fourth kilograms. That's the way it was originally written. Plus, and now this is what I've calculated, 0.2, or converted is a better word, 0.25 times 10 to the fourth kilograms. Please don't skip your units. Get into the habit. I know it feels like it's difficult to do that, but get into that habit of writing your units. That's going to make a big difference. Boy, I can't tell that's a 4. Make that, oh my gosh, I still can't tell that's a 4. My handwriting, it's so bad. There. I should have folded my screen over, and instead it's like wobbling and whatever. Okay, so now I can actually add those two things up. And importantly, I can see that this one has 2 decimals, and I can see that this one has 2 decimals. So that means that I'm allowed to have 2 decimals when I'm all done. Okay, so I added up 1.26 plus 1.26 plus 1.25 is 1.51, and then times 10 to the fourth, and it's in kilograms. Ladies and gentlemen, we are all done. Okay, so that was 14A. Let's try 14B. It says 7.06 grams, not times 10 to the anything, plus 1.2 times 10 to the negative fourth kilograms. And the answer needs to be in kilograms. Okay, so we're in grams again. So let's convert that. That's the first thing we need to do, is convert it into the correct units. So 7.06 grams times, and I draw my conversion factor. Grams is on top again, right here. Grams is on top. So I'm going to put grams on the bottom and kilograms on top. That makes my grams cancel out. And I know that it was 1 gram for every 1 kilogram for every 1,000 grams. So I'm going to do 7.06 times 1. Don't need to do that. Divided by 1,000. So into my calculator, 7.06 divided by 1,000, and I get, oh, okay, I could just scooch it over by 3. So it's I think it's 2000706. Just have to make sure I did that right. So 1, 2, 3. Yep, did that correctly. Okay, and now that is in kilograms. The problem, however, is that it is not written times 10 to the fourth. So now I need to figure out how would I write that times 10 to the fourth so that they are the same. So let's practice that. And if your brain is like not wrapped around it, just keep messing with the numbers until you get it. So I need a number. I need to be able to write it in scientific notation so that it is the same as that number right there. So let's just try this once. If I scoot the decimal over by 4 spaces, 1, 2, 3, 4, and make it 70.6, and I multiply that times 10 to the negative 4, if you didn't know which way to make the decimal go, practice, try it, like just make it go the wrong direction and then multiply it out and see what happens and go, oh no, that was completely the wrong number. So let's look. 70.6 times 10 to the negative 4. Well, if I multiplied that out, it would make my decimal go 1, 2, 3, 4. And oh yeah, that would be the exact same number as that. So that's how I'm supposed to write that number, is 70.6 times 10 to the negative 4. Now the other one is also written in 10 to the negative 4. So now I'm ready to do my addition. So it is, I'll switch colors here. 1.2 times 10 to the negative 4 plus 70.6 times 10 to the negative 4. Oops, and I told you to keep your units, didn't I? I'm really good about doing units, so I shouldn't have. I'm surprised I missed them. Okay, so when I add those together, it looks like we get 71.8 times 10 to the negative 4 kilograms. And I should be done, right? Ugh. There's one more sucky step, you guys. It's not officially in scientific notation right now because this number, the number in front of the decimal, has to be between 1 and 9, and you've got it at 71. It's too big. So now that decimal needs to be moved over one more spot. So now the final answer is 7.18. Oops, I still have to check that also if my sig figs are right. Times 10 to the negative 3. If you're not sure if you have that right, just do the math in your head. Play around with the decimal, so the decimal would go and see if that's the right number. See if 7.18 times 10 to the negative 3 is correct. Now, the last thing I need to look at is when we, oh no, it worked out perfectly. When we came up with our answer for doing significant figures, it was 71.8. And so there was one number past the decimal. This one had one number past the decimal, and this one had one number past the decimal. So we are all good to go. So we can write 7.18 times 10 to the negative 3. And I just want to make sure that that all turned out perfectly. And it did. We are done. All right, let's try 14C. 14C, I see, again, it's the same thing, but this time it's a subtraction problem. So they're just practicing this converting from grams to kilograms. So I'm going to do the grams, and I'm going to convert it into kilograms. So here it is, 2.8 times 10 to the 7th grams. And I'm going to draw my line for my conversion factor. And I'm going to put grams on the bottom and kilograms on top. I kind of wish we had to do it the other way around. I wish they would have made us convert it the other way so that you would have practice flipping it back and forth, but whatever. So grams cancel out, and we're left with 1 kilogram over 1,000 grams, and that is then the unit would be kilograms because that's what we're left with. Okay, so we're going to do 2.8. I'm going to type it right into my calculator. 2.8 times 10 to the 7th, and then times 1. I'm not going to do that. Divided by 1,000 equals, and I get 28,000 for an answer. Now, 28,000 is normal or decimal notation. It's not in scientific notation. The other one in the parentheses is times 10 to the 5th. So I want to try to get 28,000 into 10 to the 5th. So let's go ahead, and I'm going to switch colors so your eyes can see it better. 28,000, and that's a comma. The decimal is right there. So I'm going to move the decimal 5 spaces so that I can say times 10 to the 5th. So I need these two numbers. This number here needs to be equivalent to 28,000. So maybe if I switch colors, that'll make it better. So my decimal, I need to move it 1, 2, 3, 4 spots over. Oh, sorry, what am I doing? 1, 2, 3, 4, 5 spots over because it's a 5 here. So let's just practice it. If you're not sure if you're moving your decimal the right direction, just try something, multiply it out, and see if you got the right answer. So if I did 0.28 times 10 to the 5th, you could put the 3 zeros. It doesn't matter right now. It'll matter in a minute. But 0.28 times 10 to the 5th, well, let's just see what happens. If I do 0.28 times 10 to the 5th and I type it into my calculator, the decimal is going to move 1, 2, 3, 4, 5. The decimal will be here. And does 28,000 equal 28,000? Yeah, I did it right. So I'm going to erase those because I don't want them there anymore. Whoops, 0.28. So 0.28 times 10 to the 5th kilograms is this number right here. That's that amount there. So now I'm going to add them together. So let's go back to the beginning. This is the first unit, 4.39 times 10 to the 5th kilograms. Oops. And I think it's a minus this time, right? Yeah, minus, and then 0.28 times 10 to the 5th kilograms equals, and our answer is going to be in kilograms. Okay, so 4.39 minus 0.25, and I noticed they both have two decimals past the two numbers past the decimal, so that will be our significant figures. So 4.39 minus 0.25 is 4.14 times 10 to the 5th kilograms. And I think we're done because that looks like scientific notation. I'm just going to double check that I did it right. 4.11 times 10 to the 5th. What did I do wrong? Oh, but where did this is an 8. Why did I write 5 there? I'm really sorry if that's screwing everybody up. So this number is supposed to be an 8. That's why I got it wrong. And let's just quickly erase that and make that now 0.11. There, 4.11 times 10 to the 5th, and we are done with 14C. All right, let's try 14D. I see, oh, interesting. So I see that both of these are in kilograms, but then all the way at the end, I need to convert it into grams. So I don't need to do any converting at the beginning. It looks like my 14D, I missed a number. So it's 5.36 times 10 to the negative, give me a second to read it, times 10 to the negative 1. That's a 1. Kilograms, that does not look like a 1. Minus 7.4 times 10 to the negative 2 kilograms. So in order for us to do this problem, they both have to have the same exponents. So I'm going to rewrite the 5.36. So 5.36 times 10 to the negative 1, just helping you figure out what direction to go. That would actually be the same as 0.536. That's what 5.36 times 10 to the negative 1 is. So now I want to write it so that it could be times 10 to the negative 2 and still come up with the same answer. So if I move the decimal, I'm just practicing, if I move the decimal 2 spaces, if I made it 53.6, if I made it 53.6 and then multiplied that by 10 to the negative 2, 10 to the negative 2 would make the decimal go 1, 2, and would turn it back into this number. So I have done it correctly. I'm going to erase there. So 53.6 is the correct number. So now I'm going to subtract them. So I've got 50. I'm going to switch colors here. About new color. 53.6. Come back, everybody. 53.6 times 10 to the negative 2 kilograms minus 7.40 times 10 to the negative 2 kilograms. And so 53.6, I'm not going to do that one in my head. 53.6, even though I could. 7.4 equals 46.2. Not done. Times 10 to the negative 2 kilograms. In fact, I'm nowhere near done. I'm still in kilograms, so I've got to convert into grams. And as it stands, that's not scientific notation because the number in front of the decimal is 46 and it needs to be between 1 and 9. So I've got a couple ways that I could do this right now. I think I'm going to go ahead and convert it into grams first, and then I will convert it into scientific notation. So let's go ahead and do that. We'll switch colors one more time. So 46.2 times 10 to the negative 2 kilograms. See if you remember how to do this. So I'm going to draw my conversion factor. Oh, it did flip this time. Yay, we get to do it the other way. So this time, notice that kilograms is on top. So we're going to put kilograms on the bottom of our conversion factor, and we're going to put grams on the top of our conversion factor. And it's the same. There's 1,000 grams in every 1 kilogram. But now the kilograms are going to cancel each other off. When they're above and below, they cancel each other out, and we're left with grams, which is what we want to be left with. That's the unit that's still on top. Okay, so to convert this, and I'm going to go ahead and do it on my calculator while I talk, 46.2 times 10, oops, I didn't do it right, my fat fingers, 46.2 times 10 to the negative 2 times 1,000, not divided by 1,000 this time, is 462. I should have been able to do that in my head, you guys. All right, 462. Now, that is not in the decimals right here. That is not in scientific notation. We need to move the decimal over by 2. So does that mean it's times 10 to the negative 2 or times 10 to the positive 2? That's always confusing, right? Well, if you're not sure, just do it. Try it. So let's say we made it 4.62 times 10. Let's just say we did it times 10 to the negative 2. If we did that, that means that the decimal moves 2 spaces over, and our answer would be 0.0462. That is not what we wanted. So let's go back and make that all go away. And let's try 4.62 times 10 to the positive 2. If we multiplied that, that would bring the decimal over to after the 2, and then they would be the same. Hooray! So I'll make that all go away. And this, ladies and gentlemen, is our answer for 14D. All right, moving on, 16A. All right, everybody, now we're on 16A, and this is, as I look at it, I'm going to look at some important things. So the first thing I see is that everybody's in centimeters. When you multiply centimeters times centimeters, you should get centimeters squared. So there's no unit conversions that we need to do. The other thing I notice is that instead of adding or subtracting like we did last time, we're doing multiplication, and you should be like, woo, multiplication, because it's way easier. With multiplication, you don't have to worry about whether the exponents are the same. It's just a straight multiply across. So in this case, it's 3 times 10 to the first times 3 times 10 to the negative 2. And I don't actually remember what you get for an answer for that. So that'd be 9. So 9 times 10 times 10 to the negative 2. And we get 0.9 for that as an answer. So 0.9 is our answer. That's not in scientific notation. So we need that decimal to scooch over by 1. So this would be 9 times 10 to the 10 to the, give me a second, 0.9 times 10 to the negative 1. There we go. Centimeters squared. And the reason I hesitated, I want you to think about that. I'm trying to get it to equal 0.9. And so I'm trying to make 0.9 look like 9. So I want it to be 9 with the decimal over there. So what do I have to do to get the decimal over there? And if I'm not sure, if I write 10 to the 1, that's the wrong answer. If I did it times 10 to the 1, my decimal would move this way and it would be 90, and that's not what we were looking for. We were looking for 0.9. So let's back up and make this a -1, so that if we did 9 times 10 to the -1, it would equal 0.9, which is the answer that we had there. So 9 times 10 to the -1, and I'll just double check that I did that right. Where are my answers? 9 times 10 to the -1, centimeters squared, piece of cake. All right, next, everything just multiplies together. So 1 times 5 is 5. 5 times 10 to the 3rd is 1,000 times 10 to the -1 is 0.1, but I typed it in anyway, which was dumb. So it should be, did I do that right? I gotta make sure I did that right, you guys. I'm not positive. So 5 times 1,000 is 5,000 times 10 to the 1 negative. There we go. Now I did it right. I knew what the answer was, and my calculator didn't come up with it, and so I had to do it again. Go figure. So that's not written in scientific notation. So to change that to scientific notation, we need to scoot the decimal over. So it would be 5 times 10 to the 10 to the second centimeters squared. 5 times 10 to the 2 centimeters squared. And we only get one significant digit because each of those only had one significant digit. Double check to make sure that I did that one right. And it says that I did do that right. So now I can move on to the next one. Trying to look at the answers. Okay, density, remember, is mass over volume. So this is a little bit confusing. This is the same as a milliliter. So that is correct. It's in the correct units. So we do 9 times 10 to the 5th over 3 times 10 to the -1. And again, because this is multiplication and division, we do not have to worry about the exponents being the same. So you can just type this straight into your calculator and get your answer. So 9 times 10 to the 5th is divided by, and I'm going to put it in parentheses, 3 times 10 raised to the negative 1, close parentheses, equals, and it looks like to me it is about 3 million. Not about, it is 3 million grams per centimeters cubed, or you could have written grams per milliliter. That's totally fine. However, that's not in scientific notation. So to get it in scientific notation, we would do 3, and we have to get this decimal to move. 1, 2, 3. Oops, sorry, I did not do that very well. 1, 2, 3, 4, 5, 6. So times 10 to the 6th, or grams. Oh my gosh. Hello. Let's write better. Grams per centimeters cubed. And I'm going to double check that I did that right. 3 times 10 to the 6 grams. Right on. And then our last problem, everybody. And again, because it's division, we don't have to worry about the exponents being the same. So we just enter it into our calculators. So I do 4 times 10 to the negative, what is that, 3? And I divide it. Hopefully this will not run out. Divided by parentheses 2 times 10. Yeah. Give me a second. 10 to the 2 negative, close parentheses, and equals. I have that it equals 0.2 grams per centimeter cubed. And to write that in scientific notation would be 2 times 10 to the negative 1 grams per centimeters cubed. And I just want to double check that I did it right. And I did. We are all done, everybody. I'm going to go ahead and close this up. Let me know if you have any questions.